Hey guys, this is 7-4 on series, and more specifically arithmetic series. So if you haven't watched the arithmetic proof video I just put out, please go back and watch that first. It'll be very helpful in doing this section. So it's only 10 minutes, it won't be bad. So here's the definition of a series, as I mentioned in the last video. It's the sum of the terms of a sequence. Sum of the terms of a sequence. So, examples of sequences. We know plenty. Let's do a simple one. How many terms do we have? 4. So what would the series be? Remember, series would be 2 plus 4 plus 6 plus 8, which is 14, 18, 20. So this series would be 20. What if I had the sky? 1, 1, 2, 3, 5, 8, 13, forever. So that's obviously the what sequence? Fibonacci. And it goes on forever and gets bigger and bigger and bigger and bigger and bigger forever. So what is the series? If we add all those together, we get 17. No, infinity. Good. Here's a good one. So if we add that one, it's pretty obvious it approaches infinity when we add them all together. What if we did something like this? 1/2, 1/4, and we just keep taking half. 8th, 16th, 1/32, so on, so on, so on. So we go forever. Oops, I'll go there. What is that one? Think about it. Think about it. All right, think about it. So this is an example of an infinite series, but this infinite series doesn't necessarily add to infinity. It adds to something pretty cool. It adds to an actual number. It adds to 1. And hopefully we can talk about that at another time, but that is cool. If you take 1/2 and add to 1/4, so if we added these, doink, 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 doink forever, it would give us 1. That's cool. All right, so now let's go to the examples here, and we're going to find S of 8. So let's just do the evens, I think. So we got 1, we got -2, we got 4, we got -8. So in this case, okay, so let's just do general first. So in this case, this is going to be a geometric. What are we multiplying each one of these by? It's going to be -2. So 16 times -2 will be -32nd, 64, -128. We needed, that's A1, A2, A3, A4, 5, 6, 7, 8. Yep, there's our 8. So we need to add all those together. So 1 plus -2 plus 4 plus -8 plus 16 plus -32 plus 64 plus -128. Whoo! All right, this might be one you could do without a calculator, but calculator would definitely make that easier, and ends up getting us a -85. All right, so for S of 3, we are just taking the first 3 terms and adding them together. So 1 plus 1/3 plus 1/9. Doesn't matter what the difference is in this case. Would this, just out of curiosity, do you think this would be a arithmetic sequence or a geometric sequence? Tough. Geometric, good, but let's just add these 3 together. Common denominator, so we can get, let's change it to 9s. 9 9s plus 3 9s plus 1 9 equals 13 9s. And we are done. Next, S of 4, so we need to find S of 1. S of 4, so we need to find A of 1, A of 1, A of 2, A of 3, and A of 4. For us to find S of 4, we need all those. So A of 1 is going to be 1. A of 2 is going to be 2/3. A of 3 is going to be 1/2. And A of 4 is going to be 1/5. 2/5, sorry. Woo. And then we got to add those together. and that would give us our S of 4. And that ends up giving us, we would have to need the 30th probably would be our least common denominator. So 30 30ths. This would be 20 30ths. This would be 15 30ths. And this would be 12 30ths. So 30 plus 20 plus 15, so 50, 65, 75, 77. So 77 30ths would be our answer. N squared of 5. All right, you guys get the idea. And let's do this one. I like this. So it's A of 1, A of 2, A of 3, A of 4, A of 5, A of 6. A of 1 is going to be square root of 5. A of 2 is going to be 4 square roots of 5. A of 3, 9 square roots of 5. 16 square roots of 5. 25 square roots of 5. And 36 square roots of 5. And we can add these together, actually, because they all have the same radical, square root of 5. So we end up with 91 square roots of 5. 1 plus 4. So it would basically be 1 plus 4 plus 9 plus 16 plus 25 plus 36, all times the square root of 5. And that's 91. Nice. Cool. All right. Now we'll learn about this guy, the E. This is called the sum symbol. Sum symbol. On top, this is going to be your last term number. Last term number. The bottom will be your first term number. First term number. And N is going to be, this whole thing is going to be the formula. Formula for the sequence. See that? If I do a crazy line, I hold it, it goes straight. I found out you can do that with shapes as well the other day, and I'm pretty excited about it. So watch. Wow, that's cool. Don't need it, but that's cool. So we are going to expand this series and evaluate. So here we go. Let's do the even here. Even. So this one, we need to get each one. So when n equals 1, so we're going all the way to 11. So n1. So we're going from A1, A2, A3, A4, 5, 6, 7, 8, 9, 10, 11. Alright, so A1 is going to be negative 12 times 1. Negative 12. Negative 12 times 2. Negative 24. Negative 36. Negative 48. Negative 60. Negative 72. Negative 84. Negative 96. Negative 108. Negative 120. Negative 132. And when we add those all together, we get a negative 792. All right, same thing. For this guy, number 12, you just got to know where are we starting. So A of 2, and we're going to the last term, A of 6. So A3, A4, A5, A6. Here we go. So if it's 2, it's 1 over 2 minus 2. 1 over 2 minus 2. 3, it's going to be 1 over 3 minus 3. 1 over 4 minus 4. 1 over 5 minus 5. 1 over 6 minus 6. And we add those all together. Calculator would come in handy, but you don't need to. But I'm going to use one, and I already did. And that is your answer. Okay, number 12, same thing. Start with 3. Doesn't matter what this letter is, right? It's just implying the variable we're using in the function. The independent variable. Bull. A4, A5, A6, A7, A8. A3 is going to be 3 plus 1 over 6. That is going to be 2/3. 4 is going to be 5 over 8. 3 over 5. 7 over 12. 8 over 16, so, wait, 8 over 4, huh? 8 over 14, sorry, which is 4/7. And then we get 9 over 16, which is nothing. So we add these together, doink, 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 and we get this right here. Whee! Not bad. Thank you, darling. Number 16. Same thing, guys, except you multiply the 2 by everything at the end. So you do your sum, and then you multiply by 2 at the end. So we would have a of 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. And A3 would be -2, -8. And then 4 would be -27, and then -64, and then -125, and then -216, and then -343, and then -512, -729, and -1000. So we add all those together. That number would be the sum, or the sum of this finite set. And so we would still have our 2 left over. We would have 2 times whatever that sum was, and that sum was -3024, and that would give us our answer of -6048. Cool. And now we're on to the our arithmetic sequences, which leads to our arithmetic series. And I did this in the proof video, so if you've watched it, I don't need to explain. So first we know that it is the sum of an arithmetic sequence. There are 2 different formulas I gave you in the video previous, but I'm going to give you the simplest one. That was this. Ooh, whoops. Don't want a straight line there. Over 2, we could put the whole thing over 2, doesn't matter. N is going to be the number of terms. We talked about that. A1 is the first term. AN is the last term. And here we go. We are looking for A of n here. We know A of 1, we're looking for A of n, so we can find what S of 18 is. Because S of 18 is going to be how many terms? 18 times the first term, 7, plus the last term, don't know yet, all over 2. So all we need is what A of n is. And we know A of n is going to be the first term plus the difference. What's the difference? 3 times whatever the last term is here. And since we know it is 18, it's going to be 3 plus 3 times 17, which is 58. So we plug that in, and there we go. And that's going to equal 585. Nice. All right. So I'm going to do the odd now, I guess, since I'm already here. Same thing, S of 21. S of 21, the series of 21 is going to equal how many terms we are using. In this case, 21. We're going n terms, 21 terms. And we're starting with our first, -4, plus our last, we don't know, divided by 2. So we got to find our last. So A of n equals first term plus difference times n minus 1. Let's find our difference. Our difference is, what is our difference? 2.5. 2.5 it is. So let's plug that guy in. First, let's get this a little bit smaller. Whoop, whoop. 2.5, and then we're going to the 21st term. So we get -4 plus 2.5 times 20. And that gives us 441. Plug it in. 441 plus -4 divided by 2 times 21 gives us, oops, not 441. I was writing my answer down. Oh, our answer is going to be 441. This is not 441. This is going to be 46, 46, 46. So 46 plus, that's -42. No, that's 42. Divided by 2 is 21. 21 times 21 is 441. There we go. Let's try number 5. So our series is going to be to 10. 10 terms. First term, we got to find that. And we got to find our last term. And we're good. Divide both by 2. So we need our first and we need our last. So a of 1 is going to equal 6 times 1 plus 1. Which is going to equal 7. And then a of 10 is going to equal 6 times 10 plus 1, which is going to equal 61. There we go. 68, 34, 340. Piece of cake. Number 7. Same idea. I don't think I need to do that. Number 9. I will do because it doesn't start with 1. So we are not doing S of 17. What are we doing S of? Be careful because we have to include 4. So if you need to count your fingers in the beginning to get this pattern, you can. So 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's actually 14 because we include 4. So get in the habit of not just subtracting. You got to count 4. So S of 14 is going to equal how many terms? And then we have our first term plus our last all over 2. So we need to find our first term. First term. Is it going to be a of 1? What is going on here? A of 1 is going to be this guy. But what is a of 1 in this case? A of 1 is actually equal to a of 4, right? A of 4. And so we get 5 times 4 minus 27, which is going to equal -7. And then our last term, which we are looking for a of 14, which is actually a of 17. So that's going to be 5 times 17 minus 27, which is going to be 50. Ooh, I wrote not what I said. 58. So -7 plus 58, 51 divided by 2 times 14. That's going to give us 357. Okay. 68, 78. 5. Okay, so now we're on to application problems. Let's take a look. Read it over first, and then I will jump in. Okay, so let's read together now. Michaela, I like that name, is training for a marathon. She ran 2.4 miles the first day, 2.55 the second, 2.7 on the third. If this pattern continues, find the total distance she ran after 60 days. So, A of 60, we're looking for A of 1. So, S of n, the sum of that is going to be S of 60 in this case. So I don't even need to write S of n. Let's put that out of there, actually. S of 60. That's going to be how many terms? 60. First term, last term, all divided by 2. All right, so first we need to get an actual arithmetic sequence formula going here. So we know A of 1 is going to equal 2.4. So we already have that. So let's plug that in. 2.4. So really what we need is A of 60. So A of n is going to equal 2.4 plus the difference. So what is the difference? Difference is 0.15. Does that work again from this one to this one? It does. So 0.15 times n minus 1. So this is going to be 2.4 plus 0.15 times 59. Let's see what that is. That is, calculator, 11.25. So if I plug in 11.25, I end up putting that also into my calculator and getting 409.5 miles. So that is the distance she'll run after 6 days if she's increasing each day by 0.15 miles. That's how much she would have ran total in 60 days. So she increased her mileage by 0.15 a day for 60 days. On the 60th day, she would have been running 11.25 miles, and in the total amount in 60 days that she ran, it was 409.5. That is practical. Number 12, same idea. Tickets for a concert open up for sale online. The number of people that purchase tickets in each of the 4 minutes is shown in the table to the left here. If this pattern continues and the concert venue can hold a maximum of 75,000 people, find the number of tickets left after the first 2 hours. Whew. So 2 hours. So that is going to be A of 120, because that's how many minutes we're looking for. So our series is going to be S of 120 is going to equal 120 times our first. So our first minute is going to be 35 tickets plus our last, we don't know yet. And how many every tickets we have there, we subtract from 75,000, because that is going to be how many tickets we have left after 2 hours. So this is going to be how many tickets we used in 2 hours. And then we can figure out how many we have left by subtracting it from 75,000. So let's do with 120. Don't know yet. We do know A of 1. A of 1 equals 35. We did that. So our formula here is going to be A of n times 35 plus the difference. What's the difference? Goes up 8. And then we do 35 plus 8 times n minus 1. And in this case, n minus 1, or 120 minus 1, is 119. And that's going to give us 987. Plug it in. So our total is going to be 61,320 tickets. That's how many tickets we're going to use. That's how many tickets are purchased in 2 hours. Since the total amount we can hold is 75,000 people, how many tickets are left? How many tickets are left? It's going to be, it's going to be 75,000 minus 61,320, which is going to be 13,680 tickets left. There we go. Cool. Next, last problem. A brick retention wall was built such that the bottom row has 200 bricks, and each row thereafter has 4 bricks fewer than the row beneath it. Each row thereafter has 4 bricks fewer than the row beneath it. Okay, if 3,000 bricks were used, how many rows tall is the wall? Oh, this is a cool problem. So let's first get our formula. So our A of n is going to be 200. That's what we're starting with. We are losing 4 each row. So A of n, let's get that into, well, this is a little bit tricky because now we are looking for, if 3,000 bricks were used, we're looking for how many rows we use. So say, for example, we had S of something. We don't know. That's going to equal how many rows we use times the first, that's 200, plus the last term, which we don't know either, all over 2, but we do know S of n. We do know how many bricks are going to be used. So we know that 3,000 bricks are going to be used. So that is going to be 3,000 equals n plus 200. Yeah. We can do A of n now, though. So let's get, I see. I'm going to have to back up. Cool problem. Okay, so let's get this into an actual equation here that is a little bit simpler to substitute. So here we go. We get 200 plus negative 4n plus 4 equals negative 4n plus 204. Okay, that's going to be equal to A of n, or whatever our last term is. So if we had S of n, that's going to be equal to n times our first term plus our last term, which is this, all over 2. Cool. And then S of n we know is going to be 3,000. Because 3,000 is equal to the amount of bricks used, and that's going to be the sum notation, series notation. So this is going to equal n times this whole thing, 200. Yeah, we could probably distribute this now. So we get negative 4n plus 204 plus 200 is going to be, yeah, we could just write that as combine like terms here. We get negative 4n plus 404 divided by 2. And then we could actually divide each by 2. Negative 4n divided by 2 would be negative 2n. 404 divided by 2 would be 202. All this times n. Woo! This is going to be a quadratic one. I like it. So let's change colors here. We're going to have to distribute. So 3,000 equals negative 2n squared plus 202. Ooh, too much. 202n. And I'm going to make this smaller. If I can. Yeah, boy, not working. Just gonna move it over here. Okay, so we need to do the quadratic here. So we're gonna get it all into one side. So we get negative, let's add it to the left. We get 2n squared plus 202n plus 3,000 equals 0. We could factor as 0 and get n squared plus 101n plus 1,500 equals 0, because we would have a 2. The 2's would cancel out when we divide by 2, and we'd still left with 0, so we can just get rid of the 2. Alright, so we could try factoring it. Can we factor that? Ugh, that's ugly. That is ugly. Alright, so let's use the quadratic. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we get n is going to equal 101. Did I make a mistake? Oops, this is going to be negative. Negative. Yeah. Oh, no, positive, which means this is going to be negative. Okay, I was like, that can't be negative. Okay, so there we go. So now, since that is negative, we're going to get a positive 101 when I plug in the quadratic. So I get 101 squared minus 4 times 1 times 1,500 all over 2. So I'm going to get 2 results for this. N is going to be 82.91 and 18.09. Now, which one makes sense? Or do they both make sense? Could it be 83 rows tall? What do you think? What do you think? What do you think? Can it be 19? Which one are we going to use? 83, 19? How do we know for sure? We plug it in. So I'm going to see if I can find some space here. I can definitely make this smaller. Okay, so how do we know for sure? We got to plug it in. So we got to try both of these. All right, so we go back to our original equation, S of n. We know it's going to be 3,000. So we get 3,000 equals n. So let's try n as in, I don't know, 83? 83? And then we could have plugged it back into this equation to get our a of n. So a of 1, which is 200, plus, and then we get 8 times, negative 4 times, wrong one, oops, negative 4 times 83, which is going to be negative 4 times, oops. So if, let me just bring that down here. So if I had a of 83, that would be 200 plus negative 4 times 82. What would that be equal to? So that would be 82 times negative 4 plus 200. Whew, that is going to be negative 528. So let's try. Negative 528 divided by 2. Nah, that's going to be negative. So that can't work. So we know 83 cannot work. So let's try our next one. What if it was a of 19? A of 19 would be 200 plus negative 4 times 18, which would be 200 minus 36, 72. At least it's positive. All right, so we get our answer for a of 19. Okay, so we plug in 128. So now we're going to get, does 3,000 equal 19 times 200 plus 128 all over 2? Let's see, plus 200 times 19 divided by 2. Yeah, that looks good. So it must be this guy right here. And there we go. So how many rows? About 19 rows. We got to round up. Got to round up. And that's it. All right, guys.